AIM2 relation. In the first challengers questions, let us discuss. The question number 1. Write the domain and range of the following relations. Also find their inverse. Here they given R2 is a relation 1, 1, 4, 2, 9, 3, 16, 4. Order of base given. Now, what is the domain? That means first components, that is domain. Second components, that is range. Now we need to find the inverse also. So the relation is R2. R2 inverse is nothing but interchange the first and second component. When you interchange 1, 1, 2, 4, 3, 9, 4, 16. Next, R3 is a relation given. We should find the domain. The first component 1, 2, 3 is domain. X, Y, Z is nothing but range. Now when we need to find the inverse for relation R3. R3 inverse is nothing but X, 1, Y, 2, Z, 3. Now relation R4 is given X, Y such that Y equals to X, X and Y belongs to N. You need to understand the order of pair. How we should find means condition is Y equals to X. Both X, Y should be natural numbers. If I take X is 1, 2 ones are 2, and I take X is 1, for that Y value is 2. Then if I take X equals 2, 2 2s are 4. If I take 3, 3 2s are 6. If I take 4, 4 2s are 8. Similarly, it will continue. There is no end for that. Means R, I can define 1 and 2, then 2 and 4, and 3 and 6, 4 and 8. If I take 5, 5 2s are 10, because this is natural numbers and this is also natural numbers. If I take 5, 5 2s are 10, like that, there is no end, because for natural numbers, if you start from 1, 2, 3, 4, 5, there is no end. Similarly, you will get Y. Okay, now this I will consider as set X. This is Y. So R is the relation from X to Y. X and Y both should be natural numbers, and Y is 2X. If I take natural numbers 1, 2, 3, 4, 5, 6, I am getting Y. 1 is related with 2, 2 is related with 4, 3 is related with 6, 4 is related with 8, and 5 will be related with 10, and so on. So relation is infinite. So this is R4. Now inverse for this R4 means before, let us write the domain and range. Domain is 1, 2, 3, 4, 5, 6, 7. That is nothing but natural number. And range is 2, 4, 6, 8, 10, etc. That is also infinite. Next, R4 inverse. Just interchange the order. 1, 2 means 2, 1, 2, 4, 4, 2, 3, 6, 6, 3, 4, 8, 8, 4. This is R inverse. This is domain for relation R, range for relation R. Whereas you find the R inverse, range will become domain, domain will become range. Here if A equals A, B, B is XY, C is ACY, we should verify these three conditions. I have taken the first one. A cross B union C equals A cross B union A cross C. First A I have written as it is, cross B and C union. When I combine these two, what I will get? XYAC y is common, so one time you should write. We need to find the cross product of these two. Cross product means all possible order of pair: ax, ay, aa, ac, bx, by, ba, bc. This is my LHS. Now let me find the RHS. Yeah, RHS is A cross B union A cross C. That's what given in the question. So we need to take see that A cross B means we need to find the cross product of A and B. Okay, first what are the A and B? Let us come to know. A and B, A is A comma B, B is XY. When you find the cross product for that, AX, AY, BX, BY, like that you will get. A is nothing but A comma B, B is nothing but X and Y, and C is nothing but AC, Y. Now you are finding cross product of A and B, A and B, AX, AY, BX, BY. This is A cross B union A cross C, A and C cross product AA, AC, AY, next BA, BC, BY. Now this is one set, this is another set. This we need to combine AX, AY, then AA, AC, BX, BY, BA and BC. Here BY, BY common. One time we should write. Don't write two times. Now check LHS and RHS. AX, AX, AY, AY, AA, AC, BX, BY, BA, BC. So LHS equals RHS. Hence it is verified. Now we need to check another one. A cross B intersection C equals A cross B intersection A cross C. Here I will take left hand side. A I know A comma B cross B and C intersection. B and C common is Y. That is here. These two set I need to do the cross product. AY, BY. This is my left hand side. Take RHS. A cross B intersection A cross C. Here A and B cross product AX, AY, BX, BY. Cross product of A cross B is this. Intersection A cross C, A, AC, AY, BA, BC, BY. This is one set, this is another set. These two common we should find. Which are common? AY, AY common. BY, BY common. Look at the LHS, RHS. AY, AY, BY, BY. Hence it is verified. Yes. Next third one. B minus C cross A equals B cross A minus C cross A. Let me take left hand side. B minus C. B minus C means only belongs to B, that is X, cross A. A is nothing but A comma B. This we should find the cross product XA, XB. This is LHS. Let me take RHS. B cross A minus C cross A. What is B cross A? B cross A, XA, XB, YA, YB, from B to A. Next C cross A, C and A we should do. AA, AB. CA, CB, YA, YB. These two sets we should find the difference. Only belongs to this. Here YA, YA common, YB, YB common. Only belongs to this means that is these two. So check LHS, RHS. Both are same, hence it is satisfied. Next, state whether the following statements are true or false. R is a relation 1, 1, 1, 3, 3, 3 is a relation in set A 1, 2, 3, 4 is reflexive. What is reflexive condition? A belongs to A, A belongs to R. But here 1, 1 is there, 2, 2 not there, 3, 3 is there, 4, 4 not there. So 2, 2 is not exist. 4, 4 not exist. Then it is not a reflexive. Next, R1 1, 2, 3, 3, 3, 4. Set A is 1, 2, 3, 4 is symmetric. Symmetric condition A, B, B, A should be belongs to R. Here if I take 1, 2, 2, 1 is not there, then it is not a symmetric. Then R2 is 1, 1, 2, 3, 3, 2, 2, 2. Set A is 1, 2, 3 is antisymmetric. Antisymmetric condition AB belongs to R, BA belongs to R. Then A must be equal to B. Here if I take these two pair AB, PA, then check A and B. A, B, B, A. This is A, this is B, this is B, this is A. A, B belongs to R, BA belongs to R. Whether A and B are equal? No. That's why it's not symmetric. Then R3 2, 2, 1, 1, 3, 2, 2, 3, 3, 3. Set A is 1, 2, 3, 4 is transitive. Transitive condition A, B belongs to R, B, C belongs to R. That implies A, C belongs to R. If you take two order of pair, these two, this is A, this is B, this is B, this will be C. Okay, two order of pair A, B, B, C. Then AC will be 3, 3. That is there in the R3. Then you can say it is true. Suppose if I change the orders, 2, 2 is my first order. Next order 2, 3 I will take. This is A, this is B, this is B, this is C. AB belongs to R, BC belongs to R. Then check whether A and C are equal. 2 is not equal to 3. Then statement is false. Yes. Is the relation R is 1, 1, 2, 2, 3, 3 in set A 1, 2, 3 an equivalence relation. Set A is 1, 2, 3. So condition for reflexive 1, 1 should be belongs to R, 2, 2 should be, 3, 3 should be. That is there. Then it is satisfy the reflexive conditions. Next, to check the symmetric, I am considering 1, 1. It is belongs to A. Means A, B belongs to R. Again, B and A I will take. B is also 1, A is also 1. So B, A is also belongs to R because 1, 1 belongs to R. So it satisfied A, B and B, A. A also 1, B also 1. Then A, B belongs to R, B, A belongs to R. Then it is symmetric. Then it satisfies the symmetric. If you take 2 also, this is A, this is B. A, B, B, A. Both are 2, 2 only. If you take this also, 3, 3, that is A, B. B, A means 3, 3 only. So it satisfies the symmetric also. Now we should check to say the given relation is equivalence, it must satisfy the reflexive, symmetric and transitive. Now to check the transitive, I will take one order of pair 1, 1. Again 1, 1 I will take. This is A, this is B, then this is B, this is C. Here A, B belongs to R, B, C belongs to R. Then A, C also belongs to R. Here A is 1, C is 1, then 1, 1 belongs to R. That is there in the set R. Therefore, this given relation R is equivalence relation because it satisfies all the three conditions: reflexive, symmetric and equivalence. Even if you take 2, 2, A, B is belongs to R, B, C is also belongs to R, then A, C also belongs to R. That will be satisfied. So it satisfies all the three conditions. So it is equivalence relation. If set A consisting first 5 natural numbers and R is defined x, y such that x is less than equal to y is relation in a set A, then find the range and domain of R inverse. To find the R inverse, first we need to find the R. So the set A is first natural number, 5 natural number is 1, 2, 3, 4, 5. Relation, how we need to take the order of pair? Yeah, here x should be smaller than y or both can be equal. Like that condition I should take. I can take here 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Yes or no? This is greater than this, or both can be equal. Similarly, I can't take 2, 1 because 2 will be greater. X should not be greater. So I can take 2, 2, 2, 3, 2, 4, 2, 5. Next 3, 1 I can't take, 3, 2 I can't take, 3, 3 I can take, 3, 4, 3, 5, 4, 4, 4, 5, 5, 5. So this is my relation R. Here first component is domain, second component is range for R. R inverse I should find. R inverse is nothing but interchange the 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 2, 2, 3, 2, 4, 2, 5, 2, 3, 3, 4, 3, 5, 3, 4, 4, 5, 4, 5, 5. In this, we should find the domain for R inverse and range for R inverse. If you look at this, what is domain? 1, 2, 3, 4, 5. What is range? 1, 2, 3, 4, 5. So both domain and range for R inverse is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now we need to discuss the packages. Yes, PRL package. Among the following, a symmetric relation is symmetric condition x, y belongs to R, then y, x also belongs to R. Then it is symmetric. Here x is multiple of y. X is multiple of y. Then y will not be multiple of x. Okay. Suppose four is multiple of 2, but 2 is not multiple of 4, so it's not symmetric. X is a factor of y. If I consider 2 and 4, 2 is factor of 4, but 4 is not a factor of 2, so it's not a symmetric conditions. Then x is subset of y. suppose if I take x is 1 2, y is 1 2 3, then I can say x is subset of y, but y is subset of x? No. Then it is not satisfy the symmetric condition. X is equal to means x is equal to y, like that. If I take two numbers, 2 equals to 2, x and y belongs to relation R, then y and x also 2 comma 2. So 2 comma 2 belongs to R. This is x, this is y. If you change the order, 2 comma 2 only, this is x, this is y, this is y, this is x. If x and y are equal, y and x also equal, x comma y belongs to R, y comma x belongs to R, then it is satisfy the symmetry condition a comma b, b comma a. Therefore is equal to satisfy the symmetry condition. Next, if a comma b belongs to R, b comma a belongs to R, a b, b a, symmetric condition, but a is not equal to b, then the relation is said to be symmetric. If a equals to b, that is antisymmetric. Now question number 3, if a is 1 2 3, b is 2 4, S is a relation from a to b which satisfy x equals y in the roster form. This is a to b relation. X and y both should be equal. If I take 1 and 2, 1 and 2 are not equal, 1 and 4 not equal, 2 and 2, yeah, it is equal, 2 4 no, 3 2 no, 3 4 no, only 2 comma 2 satisfy x and y. Both are equal, means this is x, this is y, both should be equal. This is only one order pair. When we relate a to b, we will get, see, 1 2 they are not equal, 1 and 4 we can write, but 1 and 4 are not equal. 2 comma 2 is one of the order of pair, that is equal, x and y both are equal. If I write 2 comma 4, 2 and 4 are not equal, 3 comma 2 they are not equal, 3 comma 4 they are not equal. The relation R is defined, both order of pair, first component and second component must be equal, that is only one, that is 2 comma 2. Next, in the question number 4, n of a equals to n of b equals m, then number of relations a to b is 64, then find the value of m. Two different sets, when you are relating, the number of relations formula 2 to the power of pq, where p is number of elements of set A, q is number of elements of set B. So 2 power of pq equals 64. This is nothing but n of a related to b, a to b, okay na. Relation a to b, formula n of r, that means number of relation r from a to b defined 2 to the power of pq, that is given 64. P is number of elements of set A, that is 2, number of set elements of set B is m, 2 into m, 2m, 64 I can write 2 power of 6. Base are same, equate the powers, 2m equals 6, transpose 2, you will get m value 3. So m is nothing but number of elements of set B. Now number of a cross b is 50, number of a is 3, number of b. A cross b is means order of pair given. Suppose set A is 3 elements, set B how many elements it has, that we should find. Number of a cross b formula p into q. Here p is nothing but number of elements of set A, q is nothing but number of elements of set B. P given 3, q we should find, that is 15. Transpose 3 this side, 15 by 3 is nothing but 5. So number of element of set B is 5. Here, among the above an one-to-one relation from A to B. Here they given A is 1, 2, 3, B is ABC. F function is F relation, H relation, G is also one relation, I is also one relation. If you look at all this, which is one-to-one relation. One-to-one means elements which is belongs to set A, it should relate one of the element in the set B, then it is said to be one-to-one relation. Here if you look at this G, domain is 1, 3, 2, 1, 1, 2, 3. Range is ACB. 1 is related with A, 3 is related with C, 2 is related with B. Every element of set A related distinct element of set B, then it is one-to-one relation. In F, if I consider one of the element of set A related different, so it's not one-to-one. Here 1 is related with A, 2 is related with B, 3 is related with A. So 1 and 3 are relating with the same image, means 1 and 3 having same image, it's not one-to-one. So here one image is 2, one image is A, 2 image also A, 3 image is B, image of 1 is B and image of 3 is A. So here 1, 2, 3 all are having same image, so it's not one-to-one. So the relation G is only one-to-one. Next the question, among the above we need to find one-to-many relation. Already I took G is one-to-one. Now we should find one-to-many, means one of the element of set A must related with many elements in set B, that is F. You see, 1 is related with many elements in the set B, therefore F is one-to-many. Next question. Now we should find many-to-one relation in A to B. Already I took the relation G and F. We need to check with H and I. Here H relation, if you observe, you check the question, you may get idea. Different elements in a set A having same image in set B, therefore this relation is said to be many-to-one relation. Next we need to find many-to-many. The remaining in relation is I, it is from A to B. Many-to-many means here one is having images A and B, 2 is also having image A, 3 is having images A and B. So 2 or more elements from set A having 2 or more images in set B, then it is said to be many-to-many. Here these two are having 2 images, therefore it is many-to-many relation, that is I. The relation I is said to be many-to-many relation. Next question number 10. N of A equals to N of B equals M and the number of relations from A to B is 64, then the value of M. We know that number of relation from A to B formula 2 to the power of PQ, that is given 64. Now P is nothing but number of elements of set A, Q is nothing but number of elements of set B. Now 64 if I write in the exponent form 2 power of 6, base are same, equate the powers, then transpose the 2, 6 by 2 is 3. That means number of elements in the set B is 3. Next, if the R is a relation from a finite set A having n elements, then number of relations from A to A means the relation from A to A. How many relations we can find? 2 to the power of n power of 2. This is very important formula. Remember, when you relating set A to set A, number of relations we can find, that is 2 to the power of n power of 2. Next question. If n of A cross B equals 18, n of A is 6, n of B we should find. Number of A cross B is nothing but product of P and Q. P is nothing but number of elements of set A, Q is nothing but number of elements of set B. Now product of elements of set A and set B is nothing but number of A cross B. A cross B given, P is given 6, Q is, we should find transpose 18 by 6 is 3. So number of elements of set B is 3. Yeah. When you are relating A to A, set A to set A, number of relation formula 2 power of n power of 2. Reflexive, how many reflexive relation we will get? 2 to the power of n into n minus 1. How many symmetric relation we may get? 2 to the power of n into n plus 1 by 2. Remember these three. Based on this we need to discuss. The question number 13. If A is a set 1, 2, 3, then total number of distinct relation that can be defined over A, means from A to A we are relating. Formula is 2 to the power of n power of 2. Here how many elements are there? 3. N place take 3. 3 square is 9. So 2 to the power of 9. Okay na? Next question, 14th question number. If set A is 1, 2, 3, then the number of reflexive relation from A to A, formula 2 power of n into n minus 1. So we know set A is nothing but they given 1, 2, 3. So the number of elements is 3. So 2 to the power of n into n minus 1. N place you take 3. 3 into 3 minus 1. 3 into 3 minus 1 is 2. 3 2 is 6. 2 power of 6 value 64. Next, set A is 1, 2, 3. Then the number of symmetric relation in set A is symmetric relation formula 2 to the power of n into n plus 1 by 2, where n is nothing but number of elements. Here 3 elements. So wherever n is there, take 3. 3 into 3 plus 1 by 2. 3 plus 1 is nothing but 4. 4 by 2. 2 1s are 2 2s are 3 2s are 6. Therefore 2 power of 6 value 64. Next, emerald packages. The domain of relation are on set n. N is natural numbers defined as r equals x comma y, where such that x and y belongs to natural number. X plus 2y is equal to 5. Then is n, we need to find the domain of this relation. So n means natural numbers, we know, that is start from 1 2 3 4 5 etc. Now we should choose the order of pair for the relation. How? X comma y, 2 elements we need to select from the natural number set. The condition is this: x plus 2y should be equals to 5. Now suppose if I take 1 x place, x I am considering 1, then transpose 1, 5 minus 1 you will get 4, or this 2 if you transpose 4 by 2 is nothing but 2. 2 is belongs to n, 1 is also belongs to n, then 1 comma 2 both are order of pair for this relation. What I am telling, the condition is x plus 2y equals 5. If I assume x is 1, then 2y equals 5 minus 1, y equals 4 by 2, then y equals 2. When I consider x is 1, y is 2, both are belongs to n. Similarly, you consider x equals 2. In the place of x equals 2, if I consider this 2, if you transpose here, 5 minus 2, 3. 3 by 2. 3 by 2 is a fraction, it is not belongs to n. That is not a pair. If I consider 2, I will get 3 by 2. But it is not order of pair, because the condition is both x and y should be natural. It is not a natural number. So 2 when I take as x, y will be 3 by 2. That is not belongs to R. Next, if I take 3, x place I am taking 3. 3 plus 2y equals 5. Then 2y equals 5 minus 3. Then 2y equals 2. Then y equals 2 by 2 equals 1. So when I take x equals 3, I am getting y. Both are natural numbers. That is the order of pair of relation R. More than 3 if I take, 4 if I take, assume this is 4, then transpose 4. 5 minus 4 is 1. This 2 if you transpose 1 by 2. 1 by 2 is not a natural numbers. Then other than 4 if I take 5. 5 if you transpose 5 minus 5, 0. 0 by 2 is 0. 0 is not a natural numbers. So only 1 and 3 time you will get y. 4, 5, 6 if you take 6, 6 if you transpose 5 minus 6 is minus 1, you will get negative integers as answer. Therefore the order of pair for the relation is 1, 2, 3, 1. In this domain is 1 and 3. Okay, na? And these 2 and 1 is called range, but they are asking only domain. This order of pair we should only find out, then after we should find the domain. Yeah. Now the number of relation A cross B, if n of A is 3, n of B is also 3. Instead of this, directly we can use this formula. A to B we are finding the relation. So number of relation formula is 2 to the power of PQ, where P is nothing but number of elements of set A, Q is nothing but number of elements of set B. 2 to the power of P plus 3, Q plus 3, 3 3 is a 9, 2 power of 9 value 512. Okay, na? If A is 1, 2, 3, 4, then the number of subsets of A contained in the element 3 is, means suppose A is a set. How many subsets I can find? Formula is 2 power of m subsets. In the relation before AIM2 we learnt this, 2 to the power of m, to find the number of subsets. M is nothing but number of elements 1, 2, 3, 4. I am including this 3, so 1, 2, 3, 4. M place if I take 4, 2 to the power of 4 is 6. 16 subsets we can find for this, including 3. Now I am leaving the 3, only 1, 2, 4 I am taking. In this case, how many subsets I can find? 2 to the power of m. M is 3. 2 power of 3 is 8. This 8 excluding 3 means here 3 won't be there in this subsets. So when I consider 3, total 16 subsets I can make. Without 3, 8 subsets I can make. Then 16 minus 8 is 8. Therefore only 8 subsets. When I make a when I find the subsets for A, 1, 2, 3, 4 set A, I may find 16 subsets. In that 8 subsets containing 3. Remaining 8 they won't contain the element 3. Okay, na? So you start finding null set 1, 2, 3 separate. Then after 1, 2, 1, 3, 1, 4. Then after 2 elements, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Then 3 elements 1, 2, 3, 1, 3, 4, 2, 2, 3, 4. Then after 4 elements 1, 2, 3, 4. Like that, if you find total, you will get 16 elements. 16 subsets you will get. In that 8 subsets containing only element 3. Remaining 8, the subsets, they don't have the element 3. Now more than one correct answer type. The relation parallel is, so imagine x is parallel to y. Even if I take x is parallel to itself, then x comma x belongs to R. It is reflexive. The line itself is parallel always, though it satisfies the x comma x condition, so it is reflexive. If I say x and y parallel, y and x also parallel, it satisfies a comma b, b comma a, so it is symmetric. If I take one more line z, x is parallel to y is parallel to z, then x is also parallel to z. The condition a comma b belongs to R, b comma a belongs to R, a comma c also belongs to R. Therefore, it is satisfy the transitive conditions also. Now, if it is satisfied three conditions, reflexive, symmetric, transitive, then the relation is said to be equivalence. So, the relation, parallel relation, you are telling two things are parallel. Okay, that comes only lines. Two lines are parallel means one line if you take itself, the line itself is a parallel, so reflexive. Two lines are parallel means however you say x is parallel to y, y is parallel to x, it satisfies the symmetric condition. Then transitive, how it is? Three lines I am considering parallel lines. X is parallel to y, y is parallel to z, then x is also parallel to z, then transitive conditions satisfied. These three conditions satisfied, then it is equivalence. So all the options are true. Next question. In the set of all triangles similarity, we need to talk. Let me take two triangles. This is my first triangle. This is my second triangle. This is my third triangle. I will give a name, triangle 1, 2, 3. This is similar. This is similar to the second triangle. Second triangle is similar to third triangle. They look same, but sizes are different. Then it is similar. Looking also same, size also same, congruence. Okay. Now, if you take triangle 1 and triangle 1 itself, you are comparing. Both will be similar. Then it satisfies the reflexive condition a comma a. I am comparing these two. Triangle 1 is similar to triangle 2, then triangle 2 is similar to triangle 1, a comma b, b comma a, symmetric. Now 1 is similar to 2, 2 is similar to 3, then 1 is also similar to 3. It satisfies the transitive. If it is satisfy all these three conditions, then relation is said to be equivalence. Okay. Now, sixth question. Statement A cross B is not equal to B cross A. Yeah, it is true. A cross B not equal to B cross A. Only A cross B will be equal to B cross A when A and B both should be same. Unless A and B are equal, A cross B not equal to B cross A. That is equal only when the set A and B are equal. Now, first statement is true. Second statement, number of A is P, number of B equals Q. Then number of A cross P equals P into Q. Statement B is also formula. It is true. Both statement A and B are true. So next, let's go for the AIM3. Thank you, students.